Now that we had a look behind the scenes and had a look at the more difficult parts of JavaScript, let's come back to something simpler. Let's come back to error handling. For this here, I'm back in that project we worked on before in Express. And you might remember that there something could go wrong. If we tried to read or write to this restaurants JSON file and I renamed it to simulate that it's currently not available, then we got an error. And we handled that with that default error handling middleware here, which allowed us to send back this 500 status code and this 500 page. That's what we saw before in this course. Now that was a really useful pattern because it allowed us to ensure that we sent back some response even if something went wrong on our server. But this is not necessarily always the best way of handling such scenarios. It was fine here, but the more complex your code gets, the more actions you might want to execute in your route handlers, the less optimal this approach could get. And therefore I'm back in that simpler project or this simpler demo workspace we worked in this course section. Here I'll add a new file, errors.js, and in there I will write some code that will only run on Node.js now because it makes it a bit easier for me to show you what I mean, though the error handling approach I'm about to show you would also work on the front end in the browser side. Now here I'll again require the file system package, and that's the part that only works here in Node.js because that is not code that would work in the browser. The browser would neither understand this require function, nor do you have access to some file system in the browser. But the rest of the code which I'll write would work the same way in the browser if we leave out the file system part. And here I'll add a new function, read file. And in that function, I will now call read file sync as I did it before in this course. And I'll try to read the data.json file, which doesn't exist here. There is no data.json file in this project. So this line of code should fail. Now I would get my file data here as a result of calling read file sync, but again, this will fail. Now let's say I thereafter have another step where I output something totally else. Something like hi there as a placeholder, but of course we could be doing something more useful here. We could be storing some data in a database or do anything else that's not directly related to reading that file. Now if we execute read file here, that of course will fail, as I mentioned. If I execute errors.js, we get an error. Now this is not an Express application here, it's just some standard Node code, some standard JavaScript code executed with Node using a Node feature. But of course, this could be inside of an Express application. And if it would be inside of that application, we could again use that error handling middleware to send back a default error response. The problem just is that if we follow this approach, as soon as this line of code fails here, this function execution would stop, because if an error occurs by default, the function in which that error occurred will stop executing, and that error will be passed to the place where the function was called. And in Express case, Express is the thing calling our route handler functions, and if it receives an error by one of the route handlers, it therefore then executes that default error handling middleware because it sees there was an error and it then executes that middleware. Here we are calling that function and we're not doing anything with that error, and hence everything fails here. But that's not the main problem. The main problem is that even with Express, we might get that default error handler, but what if we actually don't want to stop executing this function just because this line failed? Because in programming, it's not always the case that you want to throw away everything and stop executing everything just because you encounter some error. You might have a plan B, you might be able to recover, or maybe the operation that failed wasn't that important. Maybe that very next line is super important though. Here we are just console logging, but as I said before, maybe we are writing to a database here. So that could be a super important operation which we don't want to skip just because this line failed here. And because you have scenarios like this, and you have them quite often, we can also wrap this line here, which might fail, with an extra construct that exists in both browser-side and Node.js JavaScript. We can wrap it with try curly braces. If we do that, then JavaScript will try to execute this code here between those curly braces. And if that should fail, we can catch the error that occurred and handle it in any way we want. And for this, we add another part to this try statement. We add the catch keyword and then another part of curly braces. And here we now put our code that will run if the code in the try block failed. With that, we can now add our own error handling inside of the function where the error occurred. So instead of then just escalating it to the place where we called read file, so instead of just passing on the error to that line of code, we handle it directly inside this function, and the code thereafter will execute just fine, because now that error is handled and the function will not stop executing because we're using try catch. And if I now save this and I execute errors.js, you see we get an error occurred, which is that error handling code we wrote here. So that's where this message here is coming from. And then we see hi there, which is this line of code which executes just fine because the overall function execution of read file was not stopped. And therefore, try catch is a very useful construct for handling errors that might occur on your own with great detail, instead of relying on general error handling mechanisms. Those general mechanisms can still be useful, but often you can also combine them with fine-grained custom error handling, where you maybe retry the operation first before reaching out to a general error handling mechanism. Or where you maybe create your own object describing the error, which you then use in your application. There are a lot of ways of using try-catch, and you'll see try-catch being used throughout the course, hence it's important to introduce and understand it right now. Now, of course, when you learn about try-catch, one obvious question that might come up is, why don't we wrap all our code with try-catch? And there are a couple of reasons for not doing that. For one, if you wrap everything, you will also catch a couple of errors that should indeed crash your application because they are simply bugs which you can fix during development. So which you as a developer should see whilst you are writing your code. And if you try and handle them, you might not spot those errors that quickly. Another reason for not wrapping everything with try-catch is that different errors that stem from different sources often should be handled in different ways. An error that stems from reading a file should maybe be handled differently than an error we might be getting when we try to get data from a database. When we fail to read a file, we might want to retry this after a second or so. So we might want to handle this in a different way. And that's why we don't want to wrap everything with try-catch, but only the places where we can expect errors in some circumstances and then only as little code as necessary. That's how you should use try-catch. But again, you'll see plenty of examples of try-catch in action throughout this course.